Hello again. I started a new project a couple of weeks ago to make a sewing desk. I am only in the concept stage and working out details before I start making sawdust. I am working in the AutoDesk Inventor 3D modeling environment, and here is what I have so far. The main dimensions are 47 inches wide and 26 1/2 inches deep, with the top surface 29 1/2 inches from the ground. So far I am planning on 5 drawers on the left side, 4 in the bottom, all the same size at 12 inches wide, 5 1/2 inches deep, and 15 inches long. A smaller drawer on top, but only 3 inches deep. It will be on casters, so it can be easily moved around, but I have yet to work out what I'm going to do on the right side. The machine is going to be on an elevator to enable using the top of the desk as a flat work surface. I am in the process of designing the elevator mechanism, and once that is done, I will figure out the cabinet work for the right side. I am planning on 14 inches of travel for the elevator, and then there will be a cover plate that goes over the hole when it is retracted. Now we will take a look underneath at my current concept design for the elevator. The gray thing here is a rail-type linear actuator, and the chrome-looking thing to the right is a guide rail linear bearing. If I end up going with this design, there will be 2 of those guide rails, one on each side of the elevator platform. The guide rails are there to offset the load, since the linear actuator cannot be placed in the middle of the platform. I do not think the linear actuator would last very long when subjected to a torsional load. The elevator will have 3 stops. One of the stops will, of course, be fully retracted. The first stop going up will be with the working surface of the machine flush with the tabletop, along with an insert to fill the gap, and the second stop will be all the way up. Well, that's the end of this part of the concept stage. I have some parts on order to experiment with the elevator design and will not be able to continue until they arrive. If you happen to come across this video during my concept and design phase, then I welcome any comments regarding the design and maybe some other desirable features to be added. I do plan on adding left side and back side fold-up extensions. Continue to watch this video if you're interested in some inventor tips regarding linking part models to other parts and using Excel spreadsheet to control the design. If you leave the theater now, be sure to subscribe to be notified when the next chapter of this project or any other project is published. Now a dive into the inventor design. I've closed the presenter file, and now we are looking at the actual 3D model. If I've done this correctly, then all of the dimensions, with the exception of the spacing of the cabinet drawers, is controlled by linking to an Excel spreadsheet. The drawer spacing could also have been linked, but I did not think it was worth the trouble in this case. This is the spreadsheet that controls most of the model. The spreadsheet must be formatted just as shown here, with the dimension name in column A, the dimension value in column B, the unit type in column C, and column D could have an optional comment, all of which will show up in the inventor parameter list. The first 2 rows define the cutout clearance for the sewing machine. More on this later. Row 3 is where I've defined the depth of any dados or rabbets. Row 4 is the depth of the main top. Row 5 through 10 defines the size of the drawers. Rows 11 and 12 are going to be the length of the extensions I plan on adding later to the back and left side. Row 13 is the height of the table from the ground. Row 14 is the height of the caster, where, in the model, that is subtracted from the height of the table. Row 15 is a little bit redundant but defines the thickness of the plywood. Row 16 and 17 defines the thickness of the top and legs, just in case I decide later to use something different. And row 18 is the width of the main table. At any point in time, I can add a new row, and then that would show up in all of the part files linked to the spreadsheet. Now here is how to link a part or an assembly file to the spreadsheet. Note that the spreadsheet must be created before linking. First, Either open an existing file or start a new one. For this tutorial, I'm going to start with a new part file since I already have a part template that includes the linked file. Once you have the file open, click on this icon to open up the Parameters dialog box. I always include that icon in the Quick Access toolbar, but you can also find it under the Manage tab. Down here at the bottom left of the Parameters dialog box is a Link button. Clicking the Link button opens a standard Windows File Open dialog box. At the bottom of the window, click the pull-down arrow for Files of Type and then select Excel files. Browse to where you saved the spreadsheet and double-click. I have always ignored this warning. Now, as you can see, here are all the contents of the spreadsheet ready to use in the design. When I start a new project like this, I will always create a template that includes a link to my spreadsheet so I do not have to link each new part. In order to do this, we must first open the Templates folder. I have never found any provision within Inventor to directly open the folder. Seems kinda dumb we're not able to do that. So to open the folder, we must first find where it's at. Click on the File pull-down menu and then Options down at the bottom. Now click on the File tab. The second field in the list defines the location of the templates on your computer. Click and highlight the path and then copy it to your clipboard. Now press the Windows key R combination, paste the path and press Enter and the folder will open. When doing this, typically I will make a copy of one of the templates already there and rename it. You can see I have already done that with a file called template_sewing. Open your copied file from the templates folder, link the spreadsheet, then save it, making it available for all new parts with the spreadsheet already linked. Now that we know what the spreadsheet is and how to link, here is a quick demonstration on how this works. For this demonstration, I need to get the model open alongside the spreadsheet so you can see in real time how everything is controlled. In the spreadsheet, I will change the height of the table and width of the table, then save the file. Now, looking at the Inventor window, watch for the Update icon in the Quick Access toolbar to turn yellow. This indicates that one of the linked files in the model has changed. Click on the icon and all the files affected by the updated spreadsheet will be updated to the new dimension. Now I change it back again to the original values and again update the model. Opening a drawer assembly to show that it is a separate model. Accessing the spreadsheet, I will change the definition of the drawer, and after clicking the update icon, all drawers have been updated to the new specification. Lowering the elevator and then turning on the cover, I update the definition of the cutout, and when I click Update, both the tabletop and cover have been updated to the new specification. And this is how easy it is to control the design of an assembly and all of its parts from one file. Changing my spreadsheet back to my current specification and then again clicking the local update icon and everything is back to where it was. I hope you learned something useful with this tutorial. The next chapter for this project will be building and experimenting of the elevator. Be sure to subscribe to be notified when the next chapter of this project or any other project is published.